person who's twirling something. So day 2 notes. We're going to actually find out what provides centripetal force. It's not a force in its own right. What are all the forces? As you're drawing that, I'm going to add some forces on the board that we've studied this year. We have studied force normal. We have studied gravity a little bit, at least it comes into play. Force normal, gravity, tension, friction. And I think the only other one is like a push or a pull, when someone or something does.
I gave units, I think.
That's a force as well. So those are the forces I could think of. If you think of another one, please add it to the fray. So we're on? Is the video on?
Yes.
I just want to greet you, Brendan, and hope that Brandon, well, last year was Brendan. This year, Brandon, welcome to our Friday edition. We're not going to be working on video very long. I'll do a couple example problems. Then we'll be working at our seats on a few problems and then lab. So hope to see you soon. You can leave it on.
Okay.
All right, that was my greeting. Here are the forces we've studied. This is not going to be added to that list. I'm not going to add force centripetal because one or more of these provide force centripetal. So let's see how that works. Have you got the twirly guy down? All right, so the first one we're going to discuss. Let me see your twirly guy. See that you're ready. Yep, twirly guy, twirly guy.
Twirly guy.
No twirly guy.
Twirly guy's coming.
Good, good.
All
right. All right, so what is providing force centripetal in this picture? I'll give you a clue. It's right there. So what is that?
It's like a little toy plane or something.
Well, that's what that is. But attached to it,
Oh, the radius?
what is that?
Oh, the
There is
string.
what?
Radius.
That's what?
Your radius.
It is a radius, it is, but what have I drawn there? Is that just,
No, it's attached onto it.
Acceleration or is it force?
It's what the guy's holding on
Is way
to.
up here. Isn't a very good drawing, is it? All right, long arm, squashy guys with long arm.
String.
The string. All right, so we've got a string that is connected from the hand to the toy that's being spun or the object being spun. So which of these are we dealing with when we have a string? Which from our list? String and tension. So the force centripetal in this scenario is provided by tension. So force centripetal is provided by tension. It's not like force centripetal is a new force. It's an old force used in this way. So tension is the force centripetal. So we'll start with a problem like that, and then we'll go to a different force here that causes force centripetal. So here's the problem. I have some parameters started. Let's say that the string, the radius of the string is 0.34 meters. So jot that down. The actual toy is 1.2 kilograms. I'm back on Pluto. The force of tension, I didn't put it down that it was tension, so I'll put it down now. Force of tension on the string is 54.1 newtons, and I'm asking you to find velocity. You have to use this formula to plug these numbers in and solve for, since we're looking for velocity, we're going to solve for v. See what you can do. See if you can put the numbers in the correct spot. Are you with us, Alex?
Yes.
What are the first two numbers again? Like, what are they correspond?
All right, this is the radius. 0.34 meters is the radius. This part right here. And this is the mass of the object that is being spun. Tension in the string and find velocity. Are you finding a spot for all those numbers? Let's see. Force centripetal. I can actually rewrite force centripetal because now I know that it is provided by tension. I'm going to call it T equals mv squared over r for clarity. And then we know tension We know mass. We don't know velocity. And we're dividing by the radius. So I'm using this formula and putting a number in each spot except v. You have to solve by v for v. Multiply both sides by 0.34, divide by 1.2. Mathematically, what's the last step then? Square root, because that'll give you v squared. So I'm multiplying both sides by 0.34, and I'll let you do that. And that will move this over here, and then I'll divide by 1.2, and that'll give me v squared. I don't want v squared, I want v. So I'm going to square root both sides, and that will be the answer. What do you have? Anyone? Emily, do you have the, Emily 1? 4, 3.9, I got it.
Yeah.
All right, I think you did
I
it.
just rounded it.
Okay, 3.9 for sig figs. 3.9, what is the unit, Emily 1? Since it's a velocity.
Meters per second.
Meters per second, that's right. Very good. All right, we should be timing this. I would say 5 minutes we've been
It's been
talking.
7 minutes.
Oh, thank you for doing that.
Oh.
All right, so tell me around 12 then. All right, so that's our first example. You'll be doing one like that in a minute. Did you get that all the way through? Did you? Did you, Alex?
I did.
Let me see.
Oh, the second one or the first one?
I've only done one. Okay, let me see. Excellent. All right, you're with us. All right, so stay with us. We got one more to do.
Oh, yeah.
All right, this time, do we see circular motions? Draw it better than I can. My bikes are lame. So draw a person driving or riding a bike in a circle. You ever do that when you're a kid? You're bored and you just went around and around in a circle.
I heard that you're allowed to go around a roundabout as many times as you want. I did that
Oh,
in
look at
front
your
of the day.
cowboy.
I ran 9 times.
That's
My
great.
mom would do it.
He's like a sheriff.
You're allowed to do that
or something.
apparently, so the guy I was in the car with just drove around 9
That
times.
was before I realized that I was
Yeah,
spinning toward plane.
keep going and going. We were like, looked at him like, what are you doing?
They'll probably get really mad at you.
It's not against the law apparently, so I mean, it's not against the law, I can't do it.
If someone's trying to enter, they
Where's
just have
this?
to wait for
Oh,
you
with
to
the
get
things in the middle.
get past them, and then they have to
in the middle.
go down before you get around.
This
Or you can go behind you.
dangerous,
Yeah,
isn't
that's
it?
what I meant.
Jump out like
Someone comes by.
Yeah, you want us to have as
Unless
much
you're going, like, really
as
fast, then you're not
possible
gonna let
on
them
those
get in.
things.
Oh, it is.
Like, okay,
Someone
I'm
here.
not, oh, no.
Yeah, apparently sometimes kids go around like, what are you doing?
Four-way stop though.
Yeah.
It's so weird. I don't know how fast to go around.
Go
the
figure it
I know.
roundabout. I've got like 5 hours per hour.
And with some roundabouts, they
Driving
don't have
so
actually
fun.
have anything in the
You're
middle.
driving such a
So,
joke.
you know, like have to just drive
Straight
around
through.
over.
I
It's a
see
three-lane
people do
roundabout.
that.
In the roundabout.
Wait, okay,
For that
3
part.
Yeah,
The
forget
freeway
this-
stop signs are
forget
weird
this
because no one
circle.
comes from that side.
Crash right over
It's a
it.
three-lane.
Over it.
Sometimes when roundabouts don't actually have anything, like some have gardens and
Yeah,
stuff.
then you shouldn't crash through.
Yeah,
That's
but like when
stressful.
when something doesn't
That's
have
stressing
anything in
me
the
out.
middle, like I'm trying to go.
I get 120 miles per hour.
You have to merge while
Yeah,
turning
it's so high.
circle.
You notice they
Okay.
don't put a solid curve, they're usually very sloped
Well, when they are.
and slight, so they invite it. All right, have you got your guy pedaling around in a circle? All right.
Yeah, dude.
What is providing, is there, when you're going around a circle on a bike, is there usually a string connected to the center of the circle?
Not unless you're really
Okay,
pumping
so we're not using tension in this problem. Which of the forces is providing force centripetal on the bike? It's somewhere in that list. What'd you say?
Push and pull.
Push and pull is not the force. That's a good one. It's providing a force, but it's not the force that makes it centripetal. Because just the force of the push or pull would make you go straight. So what is providing force centripetal? It's not push or pull. Another guess.
Force normal?
It is not force normal.
Friction.
Friction.
Pardon?
No.
Friction?
It is friction.
I was gonna guess gravity
Yes.
next, so.
Friction
Yeah,
is the
friction.
force.
Who figures this out?
And,
Flip the
Oh.
that is a really tricky one. Oh no, I tried, tested that. Doesn't look good. Let me try. Hold on, Brandon. We're gonna spin you around here. You're spit there. I
Might get
hear it
dizzy.
click. You kind of twirl it till it clicks, but it often resists. Alright, so
Oh, it's much higher now.
this time, what I'm gonna have to give you some more parameters. So I'm going to give you, I didn't give you this one, so add it. I didn't give it to you because I didn't want to give it away what force it was. MK is 0.34. MK is a coefficient of friction, and it will be in our formula. MK, hang on to that. Force, you have to know force of friction. Force of friction is two things multiplied together, MK. MK is a coefficient that is given to us, and it rates the friction between any two surfaces. So, force of friction is MK times mg. I guess that's three things. I said it was two things. mg, when we're on a flat surface. When we're on an inclined plane, that changes. But so force of friction, you have to remember, is mk mg. And mk is given. What else do I need to give you? I have to give you the radius of curvature. Here we have radius. Sometimes, if it's a car, most of the time cars aren't on roundabouts. When this book was made, they didn't have roundabouts. If this is a car,
I was gonna say, when was this book made?
roundabouts are fairly a new phenomenon.
At
But
least in our
cars would
country.
go around like
Okay.
clover leaves, right, to get onto
Miss Powell, we
to
have to restart.
expressways. So if this was a car, you'll notice your problems won't call this a radius because it's not a true circle. It's going to go off in some other, it's going to be part of a circle. So they call it the radius of curvature. So just for a portion, it's going on a circular path. So don't let the word radius of curvature
Miss Powell,
surprise you. Yeah.
maybe we have to stop the video.
Yeah.
All right, okay. All right, see you on part 2.